Hello everyone, thank you for watching this video. Now for this part of the video, we are going to do revision for PG2, WA2 revision. And this part of the chapters, we'll be looking at chapter 5, Congruence and Similarity. So without further ado, let's begin. The first part of our objective lesson for today is on enlargement and reduction of plane figures. So when there's enlargement and reduction, we will need to know this keyword called the scale factor, right? So what exactly is a scale factor, or how do we find a scale factor? So for a scale factor can be found by taking a length of an image over the length of the original. All right, so if I were to have an enlargement, the image, okay, the original becomes something bigger. So when I have an enlargement scale factor, right, the one that is usually being blown up, the larger one is the image. So it'll be the big over the original one is the smaller one. So big over small. If I were to have a reduction, okay, the image is usually the smaller one. So in this case, the original will be the bigger one. So then I will have the small over big. Okay, so this is what are some of the things that you can actually have to remember in general to find the scale factor. So now let's say, for example, we are given a diagram that looks like this, and we need to do a reduction. Reduction meaning the figure becomes smaller. So we need to do a reduction of figure using a scale factor of 1/3. What does this 1/3 means? It means I need to multiply all the lengths that I want to find by 1/3. Okay, so what do you usually do? We start off with one corner of our diagram. Okay, in this case, I noticed that this one over here is actually a slanted line. It's harder to count for slanted lines, so I'll try to work out the ones on the horizontal and the vertical lines first, right? So from here, let's do a count. Okay, from this end to the other end, I will have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 squares over here. Okay, and to reach this end point, and then I'll take 9 times 1/3 to give me the number 3, the factor 3. So maybe I can just start somewhere here. Then I'll count 1, 2, 3. Okay, and then I'll draw one more, mark my end point over here. So for one end to the other end. Okay, next, let me count my vertical number line over here. This one will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 of them here, 12 squares over here. Taking 12 times 1/3, that will give me 4. Meaning I'll move up 1, 2, 3, 4. 4 squares over here, and I'll mark this corner. Okay, so in this case, I will have this one is 3, this is 4 squares. Then the next one over here, this will be 1, 2, 3, 3 squares. Okay, 3 times 1/3 will give me the number 1. Right, so I just need to count 1 square over here, and then draw this diagram. Okay, so looking at this, I can actually complete the the diagonal portion over for this side already. But what happens if some of my diagrams have a lot of diagonals and they do not have vertical straight lines all the time? Then how can I actually count a slanted line? So count squares for a slanted line. So what I'm going to do, instead of counting horizontally, no, not horizontal, instead of counting the slanted squares, this is not correct. Okay, because these are not perfect one square at all. They may cut at a certain portion of the square, and I do not know what's the angle that they're going to cut. So what we're going to do is we need to count the horizontal and then the vertical. So count by horizontal and then vertically. So count from this point to reach this point, I'll have 1, 2, 3, 4, 5, 6. there are 6 squares over here horizontally, followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 squares vertically. So what do? I take 6 times 1/3 to give me 2. And then 12 times 1/3 to give me 4. That means on my diagram over here, I will count 2 squares horizontally. And then 1, 2, 3, 4, 4 squares vertically down. Then end up at this point, and therefore I'll draw a line to join these together. Okay, so that's how you actually use to count the slanted lines, count horizontal, and then count vertically. Okay, now this one over here, this is a image, this is A. So when I call the image of a diagram, that will be A prime. Okay, the prime, the comma on top is something like comma. That is actually meaning the image of the whatever letter, the diagram figure that you have. So this is how you draw a reduction. Similarly, you can reverse the concept to draw an enlargement. You just need to multiply the length and the size by the scale factor. Have you gotten the concept? Let us move on to the next question. Okay, next question. Problems involving congruence. Okay, congruence and similarity. For this question that we're going to talk about congruency. Now, first one over here in the diagram shown above, PQRS is congruent. So this symbol actually, this 3-line symbol actually means congruent. All right. What does congruent means? Congruent means you have the same shape and the same size. When you have the same shape gives you the same angles. But when you have the same size, they will have equal length, the same size and the same length. Okay, and more often than not, when I have the terms that look like that, PQRS, TUVS, I'm going to match the points together. P with T, P corresponds to T, Q corresponds to U, R corresponds to V, and S corresponds to S. Then what I'll do next is I will match the corresponding angles. P corresponds to T. T is this angle over here, 113. So I'm looking at P, angle P over here, that will be 113 degree as well. Q corresponds to U. So Q over here, I do not have any value for Q, and then U, I do not have any value for U. Next one, R corresponds to V. R is 74, corresponds to V angle 74 degrees. Then last but not least, S corresponds to S. So S is this angle 62. That means this angle over here is also 62 degrees. Right? Now, this is why they are of the same shape, because they have the same angles. But next, we have the same size as well, meaning the lengths are going to be the matching pairs as well. So I shall find the first one, PQ. Okay, maybe I'll put PQ don't have a line. Okay, let me start with RQ first. RQ will match with UV. RQ will match with UV. So therefore, this length over here will be 12 cm. Okay, next one, I have RS is 18 cm. So RS is 18. RS will match with VS. So RS to match with VS. Oh, this whole length over here is 18. If this is the case, this whole length over here is 18, but this length over here is 9. what's this length over here? Okay, we can find out that later. Next length, next side corresponding pair, I have another SP is 9 cm, SP. So that will match with TS. So T to S over here. This will also be 9 cm. Okay, now we have matched all the different sides and angles already. Let's work out the questions. Find the length of SV. Obviously, I already found SV is matching with RS, which is 18 cm. Now they want me to find the length of PV, which is this portion. As we can see, the whole length is 18. This portion is 9. So how to get this? I'll take the full one minus this portion. So 18 minus 9. Okay. Next one, angle PQR. Where is angle PQR? Angle PQR is over here, right? But what information do I have? I noticed that this is 1, 2, 3, 4. This is four-sided figure. So what do we have? We have actually a quadrilateral. I know that angle sum of a triangle is 180 degrees. So what's the angle sum of the angles for a quadrilateral? How many degrees? 360, isn't it? So how do I find this angle? I have 74, 62, and 113. So in this case, I'll take 360 degrees minus 74 degree, minus 113 degree, and minus 62 degrees. And we get 111 degree. Have you gotten the concept? Next one, find angle QPV. QPV, the angle is actually the angle over here. So what do we notice? We know that this whole line over here, this is 180 degrees, a straight line, and this is already 113. So in order to find this, I'll take 180 minus 113. And that gives me to 67 degree. Angles on a straight line. Have you gotten the concept? Okay, with that, then we are done with congruency. Let's move on to the next question on similarity. Okay, now this question over here, quadrilateral ABCD is geometrically similar, right? So what does the word similar, similar to quadrilateral EFGH, what does similar actually means? Similar figures means similar figures have the same shape, but they are different in size. So when they have the same shape, how do you know that they have the same shape? They have the same and equal angles. But when you talk about size, one is big, one is small. So for the different length of whichever, there is a ratio of the different sides. Right? So in this case, when it comes to similar figures, we need to a certain particular ratio. All right? So in this case, and I like to match my labeling A, B, C, D to match with E, F, G, H. All right, let me try to match the angles first. Angle A105 to match with angle E. Oh, so X will be 105 degrees. Plain and simple. Question 1, the word value. So in this case, I did not put the degree sign. Next one, B is with F. B and F, but there's no angle given, so I'm not going to write anything. C is with G. C is with G, so this is 55, so Y will immediately be 55 degrees. So Y equals to 55, since the question asks for value, so I'm only input the units. And then now I need to find Z. Z is a measurement, okay, a pair of measurement. Z is HE. HE matches with the side AD, right? So it matches with the side AD, but I need a pair of ratio. Find a ratio, right? So let us take a look at what pairs do we have measurements. My only other remaining pair is 4 and 3. Let's see whether do they match or not. So if I will have FE over here, FE will match with AB. All right, so in this case, when I write a ratio, it's up to you. You can write small over big or big over small, also can, no problem. So in this case, for me, I just put small over big. The small ratio, the small over big, that will be using the number, the side that I have, small FE with AB, so that will be 3 over 4. Right? So since I have a ratio that's small over big, if I want to find the Z, I should use the small over the big one. Right? So this figure is a bit smaller, so I'll take the small over the big one. HE with AD. So HE is Z over AD is 6 pm. Okay, and equals, we are going to use the ratio over here, 3 over 4. Then what do? We can do our cross multiplication, right? And then we solve the answer. So for Z equals to 6 times 3, 18. Then I only want Z, don't want the 4, so I divide by 4. So 18 divided by 4, that gives me 4.5 cm. Have you gotten the answer? Question ABE is enlarged to triangle ACD. That is the word enlargement. Remember what we mentioned earlier on when I have enlargement? Okay, enlargement is related. Enlargement and reduction. Enlargement and reduction is related to the scale factor. So if I want an enlargement, the scale factor is actually big over small, or rather image over original, right? So, but before I begin, I still like to label the different sides, ABE, ACD. So I'll try to match the corresponding sides. ABE matches with ACD. For me, I noticed that the triangles are overlapping. So one triangle over here, another triangle over here. So I do not like to have misleading triangles and misleading information. I know that only the triangles are similar. So what I'm going to do, I'm going to draw out and model after a small triangle. Oh, my drawing is so ugly. Okay, a small triangle ABE with the big triangle ACD. So I put the matching pairs. Sometimes the triangle, right, the question may rotate the orientation or whichever. So you probably need to draw a small one and a big one, and then you change the direction to match the different sides, okay? So for me, I'll fill in my measurements for my small triangles. This is 4 cm, 6 cm, and 2x. Then for my bigger triangle, I will have this whole portion over here. This one will be 4 plus 2. 4 plus 2, 6 cm. This one is CD is unknown, but I will have the whole length over here. This one in yellow. So this is in yellow. Okay, this one over here will be 2x plus x. So this is 2x plus x plus 3. That gives me 3x plus 3 cm. Okay, so this is 4 plus 2. All right, with that, I have my measurements and I'm going to use them, okay, to help me get my answers. And I know that I have corresponding angles over here. A is common. Angle B matches with angle C. B with angle C. And angle E matches with angle E matches with angle D. All right. So I have the corresponding angles. Now the question asked me to look for the scale factor. ABE is enlarged to ACD, to ACD. So ACD is my image. ABE to ACD, so ABE is my original. Scale factor is given by length of image over original. In this case, I have an enlargement. So this is my image. It became bigger. And that means I'll use the big over the small length. Okay, let's find a corresponding pair of ratios. So this one is 6 and this is 4, the matching sides. So it'll be 6 over 4. But always remember to simplify your fraction. Leave it as an improper fraction if necessary. So in this case, my scale factor will be 3 over 2 after simplification. So this one will be the final answer. Okay, next, calculate the length for CD. So if I want to find the length of CD, I'm taking from my original to my image. So, okay, using my scale factor over here says big over small, right? So I'm going to use this scale factor over here. Length of big over small, right? My length of big, which is CD, over the small one, which is BE, is 6 cm. So CD over the small one, which is 6 cm, is equals to this ratio, this scale factor that I had. So 3 over 2. Then with that, what can we do? We cross multiply, right? So 2CD equals to 18, CD equals to 18 divided by 2, 9 cm. Okay, so this is one method using the scale factor ratio. Another method, this is an enlargement that I can use, right? 6 become large. So 6 becomes larger. I multiply by the enlargement scale factor, it will become larger. So 6 times method number 2, from small to big. So it's at enlargement. I take 6 times 3 over 2. And that will give me the answer 9 cm as well. Okay, have you gotten the concept? So for first method, we can use the scale factor using a particular ratio, big over small, and then you match it with the ratio over here that you have found. Okay, or you find a matching pair of ratio. Or method 2, if you already know the enlargement of this reduction scale factor, and I'm going from the original to the image, I just need to multiply by the scale factor. What happens if I want to go from image to original? I want to reverse it. Then what do we do? Do we still multiply by 3 over 2? When I have original to image, I multiply 3 over 2. If I were to do the reverse image to my original, I shall need to divide by the scale factor. All right. Okay, if not, if you cannot understand so, then just do the ratio method. I know where is the problem now. There's a little bit of a problem over here. I need you all to help me to do the following. Can you please change this segment, this portion into just the length 3 cm only? All right, can you just change this to 3 cm only? That means over here, my length on this side here is 2x. This is 2x. Okay, there is an error in the question. So this one is 2x. Okay, and this whole length over here will be 2x plus 3 cm. Okay, sorry for the mistake. I think when I said the question, I might have made a typo error. So this whole thing is 2x. Can you please change the question? There's 2x and that's 3 cm. So the smaller one over here will be 2x. And this one, the bigger one, will be 2x plus 3. Now, I was saying, how are we going to find the value for x? If I want to find a value for x in the question itself, I'll need to find a ratio given to me. Okay, then find a pair of matching sides that has x inside it. So in this case, I can see that there is a ratio over here. This is the ratio for big over small, 3/2. So in this case, I should use my ratio, big over small, which is something over something is 3/2. Taking the bigger length, the larger side, which involves the x, so that will be 2x plus 3, over the side involving the smaller length, which is 2x. Then I'll equate it to the ratio 3/2. Then here we're going to cross multiply, and then I'll get 2 bracket 2x plus 3, and 3 times 2, 6x. So with this, I have 4x plus 6 and 6x. So keeping all the x on one side, I shall bring 4 over here. It becomes minus 4. So 6x minus 4x to give me 2x. So 6 cm equals to 2x. Dividing by 2, x will be equals to 3 cm. So the value for x is just the number 3. Okay, so let me repeat the whole concept over here. If I want to find the value of x, okay, and on a similar figures, what we need to do, okay, we'll try to use method number 1, the ratio using a pair of fractions. I already have a scale factor. In this case, is big over small. So I need to find corresponding sides that has letter x involved in it. So I'll take the big over the small. Big one is 2x plus 3 over 2x. And then equate it to the ratio that we have found. Cross multiply and solve for the value of x. Have you gotten the concept? Okay, sorry for some of the errors in the questions, but it's still doable, right? Okay, with that, we come to end of this part of our video, right? I have another page on construction. Unfortunately, I'm not able to show construction on my iPad directly. So if there's time in class, I'll show this question when we go through the paper in class. All right? If that's the case, I'll see you for the next lesson. Bye.